Hello everyone, welcome back. Now we're going to talk about the second part of planes. First one, how to find indices, explain them. Now how to draw a plane. Now to draw a plane, we'll reverse the calculation. We have the Miller indices. We want to draw the shape in a unit cell. And that's going to be beneficial for us when in other videos we'll talk about density. So we need to know how to draw a plane in order to find density in that plane. Now we'll start with easy thing. Then we're gonna go step by step into the cases. Now, the first plane I want to draw, it's triangular, which is the easiest one. Now, by now you understand them. Triangular has three Miller indices, no zero inside. So let's say I will have 1, 1, 1, a plane which is very easy, 1, 1, 1, to see how we're drawing it. Now 1, 1, 1, remember this information. If for the plane you have the three indices, none of them are zero, so you don't have zero in the indices, it means that the plane that you have it is triangle. Will be a triangular plane. By the way, we're not talking about hexagonal. Hexagonal have different planes and different indices there. So we have 1, 1, 1, three indices, three of them number, none of them zero. So we know that this plane will be triangle. Now in order to, those are HKL, remember, HKL. So we're gonna reverse them back to what, in order to draw we need A, B, C. Remember this please. We need A, B, C. Now A can be the same way we wrote them. This is going to be 1 over K. C will be 1 over L. So you have the Miller indices now. HKL, you will find the intercepts A, B, C. Then you're going to draw the plane. Well, 1 over 1, it's the easiest one I told you. 1 over 1 again will be 1 here. 1 over 1 will be 1. So I have the intercept at 1, 1, 1. Well, let's decide the location of origin. Now, the location of origin here, something related to your drawing. I can assume somewhere here, so that I'm going to use this cube here again. Why? Because all of the things I have are positive. Now, we'll find the location, intercept with x-axis, because we know that this is y-axis, this is x-axis, and this is z-axis. So intercept with x-axis at 1. 1 means that it's going to intersect at this point here. This is A. This is intercept with x-axis. Intercept with y-axis, which expressed by B, equal to 1. So it means that at the corner again, this is the location of B. Remember, B is only one value. Represent the distance on y-axis. It's 1. So 1 on y-axis. This is 1 on the x-axis, 1 on the z-axis. So this is origin for us. This is the location of intercept with z-axis. So what will we do? We will connect them together. We'll connect those points together. Well, connecting them together, look, just connecting the point, and it's going to give me the plane that represents 1, 1, 1. Plane that represents 1, 1, 1. This is the easiest case we might have, 1, 1, 1. Now, let's still do something with the triangle. Let's say this time I will have another one, which is, let's say, minus 2, 2, 3. minus 2, 2, 3. I'm gonna find the intercepts A, B, C. Intercept with x-axis, with y-axis, x-axis with y, with z. 1 over minus 2, yes. 1 over minus 2, it's gonna be minus 1 over 2. This is the intercepts. Remember, intercepts can be integer, can be fraction, no problem. Now 1 over 2 still remain 1 over 2, and that's going to be 1 over 3. Now I have my intercepts. X is minus 1 over 2, y is 1 over 2, z 1 over 3. So those two positive, x is negative. So we're going to choose location for origin, which the best place is here, that I'm going to use the cube nicely. So this is going to be y, this is going to be for x, and it's going to be for z. Now intercept with x-axis is minus 1 over 2, so this is on the minus direction. It will be somewhere here. So this is the minus direction for x. This is point A, which is intercept at minus half. Intercept with y-axis at half, this is y-axis, and this is half, and this is point B. Then intercept with y at 1 over 3. 1 over 3 will dividing in this section to 3 will be somewhere here. So it will be somewhere here. It's going to be 1 over 3. This is point C. So we're going to connect them together, and that's going to give us the plane that we have. It's a triangle plane, but it will be at that quarter there, so you will see it in this manner. And we said drawing triangle is the easiest one. Why? Because you have 3 points, you just connect the point easily to each other, and you will get the triangle. Remember, A, B, C, which are the intercepts, can be fractions. So some students, they will multiply by, in trying to multiply by 6. No, you don't need to do this one. HKL cannot be fraction, but the intercepts are okay to be fraction. The intercepts A, B, C are okay to be fractions. Now, let's have some other when 0 inside them. Now, let's say we're going to do 2, 0, 1. 2, 0, 1. It's a plane. HKL, we'll find the intercepts A, B, C. First, we'll find the A, B, C, the intercepts. Then we'll decide the location of origin, and the drawing. 1 over, let's say minus 2. We said that it's between minus 2. Minus 2. I have some minus inside it. So 1 over minus 2. We have minus 1 over 2. Then we have 1 over 0 here. Now 1 over 0 will be infinity. Then we have 1 over 1 here, which is going to be 1. Now what does infinity means here? It means that the plane that you're going to draw will be parallel to y-axis. B represent y-axis, yes? Now let's decide the location for origin. Now since I have negative x, I will try to manage it in a way that to use this cube, I will put y-axis here, x-axis this part here, and this will be the z-axis. I have it here. Goes for y, for x, for z. Now, minus 1 over 2 for a, which is represent x, will be at this point here. This is point A. Well, B is infinity. Yes, infinity. I cannot decide where is it, so we're going to leave this one for the drawing. Then intercept with z at 1. Now this is going to be intersection with intersect with z at this point. Look on the z, and this is point C. This is point C. This is 1. Now, the only line I can draw it here is this 2. And that's enough. That's enough. Why? Because we know that this plane is going to parallel to y. Parallel to y. So first connect those two, because we know they have infinity with b, and b represent intersection with y-axis. So we're going to what? Draw two lines at point A and point C parallel to y. At point A, draw a line parallel to y-axis. Look at this line is parallel to y-axis. At point C, draw another line parallel to y-axis until the end of the cube, and then connect those to the end of the line, connect them back together, and it's going to give you the plane which is parallel to y-axis. Has intersection at the negative 1 over 2 for x, and has intersection at 1 for z. So what we did, we only had 2 points. We connect these 2 points together. We'll connect them together. Then, since we know it is parallel to y, then at each point we're gonna draw a line parallel to y-axis within the cube. Within the cube I have it. This is parallel to y, and this is parallel to y from here. Remember, this is at the corner here, so this is the parallel, and then we'll connect the end of the two new lines, and that's going to give us the plane. Plane is a two-dimensional area. That's going to be parallel to y-axis, and this is minus 2, 0, 1. Minus 2, 0, 1. Look, this had 1 0 inside it, 1 0 inside it, so this manner we could manage it. Let's do another example. Still 1 0 inside it. Let's say we have 1 3 0 1 3 0. We have it here. No, minus. This is positive. 1 3 0. So A intercept with x-axis, with y-axis, intercept with z-axis. 1 over 1. I'm not gonna write them. 1 over 1. 1 over 3 will be 1 over 3. Just keep them simple. 1 over 0 will be infinity. Now we know this time that the plane is parallel to z-axis. Since I don't have any negative, let me just decide this corner to be the origin for x, y, z. For x, y, z. Now you realize that it's not hard to draw, but you have to know steps what you're doing. Now, intercept with x-axis is 1. So this is x-axis, positive, so this is A. This is location of intersection with x-axis. B is 1 over 3. B represents y-axis. 1 over 3, let's say somewhere here. This is 1 over 3. We're roughly deciding where is it, but not just in the middle. It's 1 over 3, something here. This is B. Now, we don't have intersect with z-axis because it's parallel to z-axis. So what we'll do, we start drawing. We will connect the two line here. The two line here. That's the only thing that we have it. Then we're going to draw two lines from each point parallel to z-axis. Parallel to z-axis. So at point A, if I draw a line parallel to z-axis, it's vertical, will be like this. And at point B, if I draw parallel to z-axis, will be something like this. Then we're going to connect the two ends together, and that's going to be the plane that we have it, which 1 3 0. 1 3 0. So I have 1 0, 1 parallel to z-axis. This is the plane that we have it. Infinity means parallel. Now the last things will be enough for this plane. We'll be having 2 0. You see how we're dealing with 2 0 in the drawing. Now let's say this time we're going to draw a plane which is 1 0 0. Now I have 2 0 here. I have 2 0 here. To see how we're dealing with this 2 0. Well, first finding the intercepts A, B, C. 1 over 1 will be 1. 1 over 0 will be infinity for y, and it will be infinity for z. So I have 2 infinity now. 1 point, 2 infinity. Well, let's assume this is the origin, we have it here, and this is axis, and this will be y, x, z. Now, the only point that I have it is intercept with x-axis at 1. We only know this is at 1, this is a. That's it. I don't have second point, I don't have third point. I didn't have. So what will you do here? You have to follow this procedure. You only have 1 point. You only have 1 point here. Then, take one of the axes. Since it's parallel to both of them, it's parallel to both, you have to draw 2 lines starting at A, one parallel to Y, one parallel to Z. Well, first line I'm drawing, this is parallel to Y, and I'm drawing another line at A, it is parallel to Z. Then, still not enough, yes? What I have to do, at the new ends, for example, this is A, yes? Imagine this will be A1, and this is A2. Put them like this so that you, when I'm talking about them, you know what does it mean. When we draw a line from A parallel to Y, you will have a new end. When you draw a line starting from A parallel to Z, you will have a new end. Then what will you do? At those ends, you will try to draw again parallel line. This is already parallel to Y, yes? Parallel to Y, parallel to Z. Those are two parallel to Z, you will draw parallel to Y. So basically the line you will draw in to finish this plane must be parallel to Y and parallel to Z. Like those two, the tops are parallel to Y, the sides are parallel to Z. Repeating this procedure, we said that you only have 1 point. At this point, you will try to draw lines parallel to the X and Y. Parallel to Y and Z. Well, you can do it in this manner. Start with point A. This is parallel to Z, yes? So parallel to Z, continue. Parallel to Y, then parallel to Z, and parallel to Y. So you can have this also round manner. You can go up, which is parallel to Z, then parallel to Y, then parallel to Z again, then parallel to Y, until you will come back to the same point. So you will end up a rectangle. Remember, when you have 0 to 0, you will have a rectangle which is one of the faces, or maybe in the middle, as well, but it will be a rectangle. So with a vertical rectangle or a horizontal rectangle, you may have it. 1 0 will be inclined. We showed to you 1 0 will be inclined rectangle. Now let's do another one. To see. Let's have something this time with the 0 0 2. So you have 0 0 2. The intercepts A, B, C. A is infinity, 1 over 0 infinity. For B, 1 over 0 will be infinity, and then for C will be 1 over 2. Well, deciding the location of the origin, this is origin. So we only have 1 point. Remember, if you have 2 0 in the plane, you will have only one intercept, which is here we have 1 over 2 for Z. So we know that it's somewhere intersecting Z axis at this point, which is C, which is point C. That's it. I don't have any other things. The other two are parallel to X, parallel to Y. Well, we will continue drawing line at this point parallel to X, parallel to Y. starting in this manner. This is parallel to x, this is parallel to y. We're starting at point C, we're trying to go around and come back to point C with parallel lines. Parallel to x and again parallel to y. You will have the rectangle that you have it, which the four sides, two of them parallel to x, two of them parallel to y. Well, if you don't like this going around, the other way that we're saying that, draw a line parallel to x-axis from point C and draw another line there parallel to y-axis. Then go to the end of that one, the end of the new lines, again try to draw parallel. Well, at the end of the first line, we're trying to draw parallel to y-axis, and at the end of the second new line, we'll draw another parallel to connect it together. Well, I mean, the end, we have three lines, you just simply connect them together. Yes, that's also the way to explain it. But remember, the plane that you will draw with, look, two edge parallel to x-axis, two edge parallel to y-axis, and it intersect at z-axis with z-axis at 1/2. This is how we're drawing plane in unit cells. When we have the HKL, the Miller indices, you will convert the indices to intercepts ABC. Then when you have the intercepts, you will try to draw them. Now, three general intercepts, we have them. We can say three general plane in the except hexagonal in all the crystal systems, which mainly we're focusing on cube. We have three main, where all of the indices are numbers. For example, 1 1 1 or 1 2 3, they are number, none of them 0. That's basically give you a triangle. 1 0 1 0 gonna give you, I'll just show you something. Those are their indices, gonna be all numbers. You have three numbers HKL, they're not 0. For this we call them inclined rectangles. Those are, they have 1 0, they have 1 0. For example, this is an inclined rectangle, has 1 0. And if you have a face, that's gonna have 2 zeros. I think we had it somewhere here. Yes, and those are, they're not inclined, they're the face, they have 2 zeros. They have 2 zeros there. Like for example, those are, we call them inclined, they have 1 0. So the 0 can be anywhere, let's change the direction. 2 0 will be the flat rectangle we have, so it will be the face, the middle, it's not inclined. And this is when three of them, this is basically the three general cases we have it for planes. Now there are a lot of examples, you can watch them, you can draw them, and if you have any questions, you can let me know through the group or during the session. You can ask your question. Thanks for watching.